Hi folks, so in this video here what we're going to do is we're going to use the axonometric plane method, and you can see here I have it previously set up. This is actually done from a previous video on showing how to do the setup, and we're going to use this method to complete this problem here. So I'm just going to zoom in on the problem. So these questions actually come from the Graphics and Design and Communication textbook. It's question number 1. Okay, so it's a good introductory question. We're given an elevation view of a solid here, and we're given the plan view of it here. And what I've done very quickly is I've sketched in the 3D version of what the actual outcome is going to roughly look like. Okay, so what we're going to do is we're going to have to draw the elevation view, obviously in the appropriate plane, the plan view obviously in the appropriate plane, and then bring the two of them together to make this. Okay, that's what we do in axonometric. We're working from the 2D back to create the 3D. Okay, so we're using the isometric view of it first of all. So just before I start that, I'm going to do a little bit of maths here. Obviously, my overall width of the object, you can see 40 plus 10 is 50, just so I know that. My overall height of the object, 15 plus 8 would be 23, plus 18 would be 41. So that's my height, just so I can mark those numbers. And my overall length of the object would be 15 plus 25 is 40. 40 plus 8 is 48. 48 plus 29, if you think of it as 30, would be 78, so 77. So my length then is 77. Okay, and how I got that, 48, 29, so I imagine that was 30, I made 78, but then I took off 1. Okay, so there's the 77. So they're kind of my overall lengths, heights, and widths. Now, I'm going to start applying those and then inputting those. So, what we actually have here, okay, is, I'm just going to zoom down now, on the sheet, based on my setup, okay, for anyone doing this question at home, I put kind of the midpoint just roughly in the middle page. I'd keep this, when you're doing this question at home, for the midpoint, I'd keep it a little bit higher. I'd put it maybe about there, because you can see here I'm just after adding on an extra kind of sheet underneath, because I didn't leave myself enough room to do the plan based on my setup. Okay, I could have actually just brought this line up a little bit further as well. Okay, and I probably would have fitted then. So I'm going to start off by inputting the elevation over here. Okay, so for the elevation, I obviously have the heights, so forward, and then the lengths. So I'm going to put in my overall length and my overall height. So my overall length is 77, the height is 41. So from the corner where the Z is, I'm going to measure 77. So I'm using red bar for my construction lines. So 77, and my height then is 41. Now what I want to do here is I'm going to use sliding set squares. So sliding set squares, first of all, this is how I like to do it. Using the long edge of the 45-degree set square, I'm going to do a parallel line from this point here to the X edge, and then if I rotate it, I get the perpendicular, which will now be parallel to the Y edge, and from this point here. So everything from my elevation has to fit inside of that there. So now I'm going to put in the various other heights and lengths. So my lengths are here, 15, 25, just zoom in there, 15, 25, 8, 29, and then my heights are 15, 8, and obviously 18 left over. So I'm going to put those in. So, starting off with my lengths, I'm going to start off with 15. Then after the 15, I have 25. And after 25, I have an 8. There's all my lengths. I'm now going to put in my heights. It goes 15 first, so 15 upwards. And then an 8 upwards, I think it is. Yep. So 8 up to 0. Marking it like that. Once again, same method. I'm going to do my horizontal lines. Okay, rotate it ever so slightly, and you'll get the vertical. Now, I might have to just move this down a little bit further. There we go. Just so I can get it in. There you know. We have now drawn our elevation. So, using my set squares now, I want to heavy in the important detail. So there is the elevation completed. Now what I want to do is I want to complete the plan. So for the plan, I've obviously got the widths of 40 and 10. So they're going to go along this line here. And then I'm going to put my lengths along this line. So start measuring those. So I'm going to go 40 and 10 along this way. Should be 50. Perfect. And then along this line, I'm going to read it from the 29 first of all. I'll actually mark the 77 first so I know everything fits in. So there's my 77. And then I'll actually mark it from here actually, sorry. So the first one there is actually 15. Plus the 25 will be the 40. And then plus the 8 will be 48. So 15, 25, 8, which would leave us 29 left over. Now, just zoom out a little touch there. I'm going to draw in that plan view. Now, luckily enough, this will always be at 45 degrees. So you can see here, just using my T-square set square like this, okay? So these lines here, I'm going to project them down 45 degrees to the left. And then these lines over here, project them 45 degrees to the right. There you know. I'm going to heavy in all these lines. And there you go. There now is the plan view completed, okay? And they are the only two views that we did have to complete. Now we're going to use those to actually create this structure here in the middle, okay? Which is going to be on our axonometric plane here. Okay, so how do we do that? What we're going to do is, obviously we've got the 2D views here. We're going to project all the lines from this view, or all the points from this view, the important points, back at 30 degrees. And all these ones from the plan, we're going to go up, vertical. So first of all, I'm going to start off by building the first base platform. And the base platform is from here to here to here to here. So every one of those I'm going to project upwards. You'll see here with the Y one, it's already in line. Upwards. And then finally on this one, upwards. Don't worry, it's not always going to work out that it's in line with your triangle. Okay. Now what I want to do is from this point here, this point, this point, and this point, because that's the elevation view of that block, I'm going to project them all down at 30 degrees. So there's the first one. There's the second. The Z one is already brought down. And then this one here. Now, depending on my accuracy, this point right here, this one, because that is where it meets with the front one here, should meet up with this one here at 30 degrees. Likewise, this one should meet up here. And then this one here should meet up with this one at the back. We're building that little block there. Yeah, I'm not quite happy with that. My accuracy is good. And there we go. You can actually see the outline of the block now. Here's the front face. Here's the side face, and here's the top face up here. Okay, I can actually heavy in some of that based on my sketch. I can see I can heavy in the front face, the side face, and a bit of the top face. Okay, so just to give the object a bit of structure. Okay, I'll just heavy in a little portion of this and a little portion of this because it'll give us a guide of obviously where we have to go with that. Now, the next section I'm going to have to complete is this kind of like seat-like portion here. Okay, if we just refer back to our sketch, okay, you can see kind of like a seat portion up here. So what I want to do is with this, I'm going to project all these points up and all of these ones down at 30 degrees. Okay, so bring all those up. We'll start off by building maybe the front face of it. So there's that one. And that one. Now where that front face is right here at this point and this point. I brought the front face up. I need to bring down the front face points from the elevation. To bring those down, I'm going to go 30 degrees down like this. I think it's actually that one. I'll do the exact same with this one. Okay, once again, heavy in, bit by bit. If you need to figure out where the object is, yeah, just make sure I have the right one. So there's that front face there. Okay, so now I can see how far to heavy in this edge. So I've now got that front face. I know that face is going to go back at 30 degrees. So this is going to go back at 30 degrees. And this one is as well. Okay, likewise with this point. Remember, it is a true isometric we're trying to get. Now let's find those points. So from here in my plan view, I can bring this one up and this one up. So I project up, try not to slip like I did there. Okay, and now heavy in a portion of this. And just to make sure I have the right one, yeah, I have it there. That one will go as far as there. I'm just going to heavy in this a little bit. And this one a little bit. Just to give me a guide of where it is going. Okay. Now what I want to do is I want to project down this point and this point. Because that will show me where they are finishing. Okay. And they are now finishing right here and right here. So I need to connect the two of those, and you can see it's working out perfect for me. They're working out nice and accurate. So there's that side face done. Now, you might ask, how do I actually complete the rest of it? I don't actually need the rest of this detail up here. At this point here, this line, because it's parallel with the ground, is going to project back at 30 degrees. This point and this edge is parallel with the ground, all at 30 degrees. And you can see here where this line meets this line is a kind of, I suppose, almost intersection point or a pinch point. From there, I know it's going to go upwards to hit this line, and then from there at 30 degrees as well. Any flat surfaces will all be at 30 degrees, or sorry, parallel with the ground, so they'll all project at 30 degrees in isometric. And there you know, you almost have the drawing completed. It's just a case of heavying in the detail. And I think I have a little bit back here. That's the back edge. And there you go. There you have it, guys. That there is the axonometric view completed using the isometric method in Axonometric. Okay. Now, some of you might ask, why haven't I put in maybe hidden detail there? You do not have to put in hidden detail in Axonometric. Okay. So that is the question completed, guys. I hope you found that helpful.